want to focus on similar mean hash signatures, then we can find some applications to that. So far what we want to do is to place similar documents into the same bucket or into the same cluster of documents that have a similar description. So these hash functions that we're computing allows us to find similar documents. If we want to hash objects, such as the signatures with the similar objects end up in the same bucket at least once, while others don't usually do that, then we can partition into bands and create candidate pairs. So candidate pairs are those that share a bucket, and we will pick some threshold. Let's say similarity threshold is a fraction of the rows in which the signatures agree to be considered similar. So we need to pick some threshold when we're calculating this similarity, and it came out to 0.4. Does that mean that they are similar? Or does it have to be like 0.9 or 90%? So the user decides a threshold. So we will pick a threshold, and we will say if it's equal or more than that number, then the pairs are considered similar. So we will divide the matrix into bands of rows. That particular one particular band will have a corresponding hash function to it, and for each band, the hash is a portion of each column divide them in the rows into bands, and let's say this is one band, and there is one signature that corresponds to all the items in this band. There could be a number of rows in a particular band. And so if we do that, for each band, the hash is a portion of each column into the hash table that might have a number of buckets in it. We want to make this number of buckets as large as possible. So we have one band, there could be one or more bands. If the hash comes the same to one or more bands, then those are considered similar. These parameters can be changed depending on the type of data that we're using, and if we're not getting very good results, we can adjust some of the thresholds or the number of bands that we use, or the number of buckets that we use. So this is how it looks like. So buckets are here. These are the bands, and that's the signature that corresponds to all the items in these bands. So the candidate column pairs will hash to the same bucket for one or more bands. So if we look here, column 2 and 6, are considered similar, but 6 and 7 are different. So if they end up into the same bucket, then they are similar. So this one and that one is similar, this one and that one is similar. And if they end up in different buckets, then they're not considered similar. We can calculate the percent in which they're similar. So that's the point of computing this value here. So let's say we can tell they are 80% similar. So if, let's say we have 100,000 columns. The signatures are just some integers. So they will take up some space. If we're looking for items that are 80% similar, if we're just to compare all of each one with each, that's a significant computational time. But if we follow this strategy that we just have seen, let's say we choose 20 bands or 100 bands that are each taking up 5 integers, then we can calculate similarity fairly quickly for this large number of documents. Now, if we do that, though, we are definitely going to miss some pairs, and there is a way to determine how many we have missed. So let's say if we had that many, 100,000 columns, the probability of the two columns are identical in a particular band will be 32%. Probability that they're not similar in any of the other bands is very, very small, 0.00035. So that there's going to be some mistakes. That's the error rate. So these will be pairs that are similar that are missed by this algorithm. And if we have, so this is if the documents are 80% similar. If they are lower than 80%, then the error will be even less. Let's look at an example to match customer records. So far we've been looking just at some text documents.